Hello.
Hey, everyone.
How's it going? You can tell that we're live because Fowler arrived at the studio 34 seconds ago.
I'm on coffee.
Everybody is panicking.
Running on coffee.
So thank you all for joining us today. There's been lots of excitement about .NET Aspire since the two best people in the keynote talked about it a little while ago. And today we are going to tell you a lot more. So, I'm Glenn Condren. This is David Fowler. I am the PM lead. I probably just smacked my microphone. Apologies. I am the PM lead for the .NET platform team, and
I'm the distinguished engineer on .NET.
Yeah. So let's, without further ado, get into some slides for .NET Aspire. My plan today is to talk for a little bit, but as quickly as possible, well, maybe as quickly as possible, get into demos. The vast majority of this talk is just going to be in Visual Studio, showing you what Aspire looks like and talking about it. So, get prepared, settle in, ready to see lots of code.
Live coding.
Live coding.
No mistakes.
All of the hilarity that will no doubt ensue, right? Okay, so first slide. Let's get going. Fowler is driving the slides.
Let's go.
.NET Aspire.
All right.
So the first thing I wanted to talk about is a little bit of the history of how we got here with Aspire and cloud native in general. So we've been doing this for some time. Probably almost since the beginning of .NET Core. I remember the very earliest examples of us getting Docker working where we had to explain what Docker was before we could show people the demo because they didn't know. And then this slide is just like a cherry-picked set of things that are examples of, we've been doing a lot of individual features, bits and pieces, all over the stack to try and make it better and more capable for building apps for the cloud for years. And all of you have been building amazing applications. Sometimes I'm blown away by what you all build and what you managed to pull off with .NET. You see health checks, Poly, gRPC, YARP, all of this amazing stuff. But next slide. When we still knew we hated to do more, like even with all of those capabilities that we were building up, then we still had quotes like these, which you might have seen briefly in the keynote. We still have people saying it's kind of overwhelming. The amount of choice is really large, and that's not necessarily bad, but the paved path is really kind of obscure. I don't know if these pieces are all supposed to go together. It kind of keeps me up at night. Not that the package is bad that I've chosen or the path that I've chosen, but is this bit supposed to go with that bit? Were they not designed to work together? How am I supposed to figure this out? And then there is also just an overwhelming amount that developers now need to know. We're being asked to do more and more and more with less and less as time goes on. And that also becomes overwhelming. You now feel like you're asked to be an expert in things that you never had to be an expert in. And then the last one, which I think has probably been true since the beginning of time, but is also far worse in the modern world, is just nothing seems to work together by default. And so we started this journey after getting a lot of those quotes and think here with all that in mind. At the beginning of .NET 8, we were doing kind of a tour. We were looking at, okay, well, what is everybody at Microsoft who are building cloud native applications doing? What do they need? And that largely fell into two broad categories. We saw a lot of libraries that were filling gaps, just the bits and pieces like log reduction and things like that, right? You'll see a lot of those libraries appear as part of .NET 8 as packages, independent to Aspire, but the part of the whole, because they are about filling gaps that we noticed that people were needed to write. And then the other, which is more related to Aspire, were these wrapper libraries. They would take a dependency and then kind of configure it for telemetry, shim it into their systems, put retry policies around it, integrate it with, and then make sure you could integrate with DI. They became kind of the core of what components eventually became, which we're going to talk about later on. And then we also did some experimentation. So for those of you who tried Thai, and Thai was an experiment that myself, Fowler, Ryan Nowak, a few other people worked on a while ago, where a lot of the same concepts that you see in Aspire appeared in. It had a dashboard, developer dashboard, but it wasn't exactly the same. It was YAML-based, it gave you the option to run as containers or not in dev, and it had a whole deployment experience built into it. Whereas Aspire doesn't tackle any of that deployment part because it was the part that didn't resonate from the experiment. So we took lots of lessons learned as building that, and all of you who have used TIE, thank you.
Thank you.
Thank you. Like all of your feedback, all the survey responses you did, the bugs you logged, and the discussions you had with us went a long way to helping us build what now is Aspire. Next. But even with all of that stuff, even with TIE, with all of these things, distributed applications are just fundamentally hard still. It was very difficult to, it's very difficult to get started, to figure out what to do. And so we built Aspire. But to give you an example of this, how do I get my front end to talk to my API? Like, what is the port? What is the URL? How do I run all the projects locally? How do I get the end-to-end to work? What is about monitoring? What should I use for monitoring? Should I be scraping? Should I be using OpenTelemetry? Like, what does APM even mean? I don't know. Like, how do I run Redis? Do I need to install Redis? Do I need to install SQL Server? Should I use containers? Should I not use containers? How do I know what config options I need to set up? Should I be using environment variables? Should I be using Key Vault? Should I be using local config files? Like, how do I know that all these libraries are supposed to work together? What is the right resiliency policy? Should I be doing exponential backoff? Should I not be doing that? I don't know. Is the thing that I'm depending upon doing retries? I don't really know the answer to that either. Let me go and spend 4 months researching. I hate it here. Like, it is super hard to get started and try and build an application like this, and just answering all of these questions, which are all important and all very, very, very difficult as you start, let alone thinking about where am I going to deploy it, which of the platforms am I going to use, like all of that. And that is even before you get to the reason you're actually getting paid to solve somebody's business problems. It's amazing where we've landed up. So, our solution to a lot of these questions, a lot of these problems is Aspire, a stack for building observable, resilient, configurable cloud-native applications with .NET. We include a curated set of components, so those libraries we talked about earlier, those kind of shim libraries, things that are configured by default for the environment we know you're going into. They give you health checks, they give you config, they give you resilience. There's a cool schematized config story that I don't think any of you have seen yet that we're going to show you later on today. And how can we make it easy for you to discover, acquire, and configure all those dependencies, and then support you through the life cycle of your application, from the getting started phase into production, monitoring and diagnosing problems, evolving your application through the whole inner and outer loop of your dev cycle. That is what we're trying to do. We're focusing on developer first, developer productivity and inner loop stuff, and integrating as naturally as possible with all the ops tools that you need to use or whatever you want to use to get into production today. And so, I guess that is my spiel at the beginning. That is where we came from. That is the history and how we got here and some of the problems. And now, I believe over to you.
For demos.
For demos, which is most of the rest of the talk.
All right, so I am low on sleep and high on coffee. So
excellent. Nothing is going to go wrong.
We are going to do...
This is going to be amazing.
Live demos. And the demo So Aspire has been what the team has been working on, or a subset of the team has been working on for at least, I want to say, like 6 months. And we kind of like started from where Glenn spoke about, but one of the big things we wanted to do was to make sure that we were on the right path. So as we built Aspire, we actually used it to build eShop.
Yeah.
So it was used as, to prove that the actual, platform was working well, was acting well.
It was amazing the bugs and inefficiencies we found just from like using Aspire to build up just the demo app, right?
Exactly.
Like that eShop architecture diagram that I believe you saw at the beginning of the keynote. When you run that and then you see 1,000 requests going to a database and you're like, that doesn't seem like the most optimal way of doing this thing.
Yeah.
And it made it very visible. And that was part of our kind of proof that this thing was real. Is that
it gave us confidence.
Yeah, it gave us a lot of confidence.
All right, so I'm going to start a new project. And I could do an Aspire app in the brand new VS 17.9 Preview 1. You'll see if I type in Aspire, there are 2 templates. There's the .NET Aspire empty, which has the orchestration app host and the service defaults project.
Right.
Then there's the start application, which I also showed in the keynote if you didn't see it, which has a Blazor front end, an API backend, and a cache for Redis.
Yeah.
And I want to build up from scratch to show you how we got to Aspire from from
If
nothing.
if you want to kick off the tires and try Aspire, jump into the starter app and
Exactly.
explore. If you want to create an app and then slowly build it up and add your stuff together and stitch it together, start with the
Either
other
way
one.
works.
Yeah.
So I'm going to build a new Blazor front-end application using the new Blazor.NET 8 that Dan just showed in all of its awesomeness.
Yeah.
Let's do Blazor front-end 3.
You see a checkbox right there?
This
down the
checkbox
bottom?
is brand new
Yeah.
in list and Aspire orchestration.
Right. So this is if you were creating a Blazor, starting with, in this case, a
brand new
Blazor app, but then you could just start with, I'm going to have the web app. I also want all the Aspire stuff immediately.
Right.
And then I'm going to start adding more stuff in from the beginning.
So you can start empty, add Aspire. You can start, with Aspire.
Yeah.
All the options are there for you. So I'm going to minimize this and then just create a new project.
Yeah.
All right, new project, very simple, no magic. One single project I'll build to make sure it works. And this isn't recorded, so I can't new get package restore. That's not great. This is supposed to just work. Oh, build succeeded, perfect. We're gonna ignore that and make sure it works.
Wow.
Gonna run this.
Unlike the keynote, there's no fixing it in post.
We can't fix it in post. All right, so we have home, counter. This is your typical Blazor app.
Right.
And weather.
Yep.
Now, weather is a local component. If I look in my components, pages, weather, I'm getting weather forecasts, in memory.
Randomly.
This is what you do, yeah. And it has a nice delay here to make ourselves look better when we fix the perf issue.
Yes.
Right, for later on.
Yes, excellent. I like it. Right.
So let's, instead of having this be, local, let's pull the weather from a backend application. So I'm going to add a new project. Still no Aspire, no magic.
Yeah.
Look for API. And I'm going to make web API, yes. I'm not going to change the default. We're not using controllers
you could
today.
have missed in Aspire here, but we're not doing that deliberately in this demo flow. But again,
could.
in all of there's a bunch of different ways to bring Aspire into an existing app or a new app.
Right. So let's make the backend application now. So now we have our first distributed system.
Yeah.
Right? Front end, back end, and now I have to make it work. So my front end wants to get weather from this weather forecast endpoint, which is the same logic as on the front end, but in a backend API. So we're making ourselves, we're getting paid more money to build a distributed system that runs in the cloud.
Sure.
So the first thing I have to do is to change this local weather to call the backend API.
Right. So you need the URL of the backend, right?
A weather client.
Yep.
Weather API client. Let's call it that.
This is using the typed client stuff that we've had for a little while.
It is.
It's one of our earlier attempts to make doing HTTP to in this environment better. Yeah.
You saw that? Look at that.
Oh, magic.
Beautiful.
Nice.
All right. Let's take in the HTTP client.
Primary constructors.
And let's do, I don't think I have Copilot turned on, actually. It won't help me this time. Let's make a weather forecast.
Can't code anymore with that Copilot.
I can't play with it anymore. But you know what I can do? I can copy and paste.
Yes.
So I have the weather forecast class, from here. I'm going to take this, navigate back to here, make this class public. So I'm going to create an array of weather forecasts, get, look at that. All right, that's not Copilot, but it's good enough.
Yeah.
And that's what we want to do. And we are going to make this do client.get from JSON async.
Yep.
Hopefully you'll know what this is, to get a JSON payload from the backend API.
Yeah.
I think the endpoint was called weather forecast.
Was it? Oh, that's the URL in the new API project by default.
That's right.
It's that URL / weather forecast
Let's
to
make
hit the
sure.
weather endpoint. Yes.
Weather forecast. Let's copy and paste just to make sure I didn't typo. Perfect.
Yeah.
I'm going to await this and then show you some C# magic.
Ooh.
So if it's null, it returns an empty array instead. Perfect.
That's a new language feature as well.
No error handling. It's good.
Yeah.
It's good.
Nice.
All right. My code is almost perfect. And now I have to wire up this client to the DI container. So I'll go into program CS, and I
guess we should explain on that last one. It means if it returns.
Yeah, we should. So this
empty...
just says either return me the JSON payload, and this can be null.
Yes.
And if it's null, I want to fall back to empty array.
Right, and those square brackets are a shortcut for a collection that satisfies. So
beautiful.
You get a collection type.
Empty array.
And later on, if you were to change it to some other type of collection, it would just work without you changing it, for example, which is magic.
Well, this isn't list, so I have to change it too. But
yeah,
I'll leave it.
But if you were to later on refactor to list, you wouldn't have to change the square brackets. It would
Correct.
still work, which is the cool feature.
So the last phase is I'll come in here and use the normal not a new feature, typed HTTP clients. Add the weather HTTP client. I get back the HTTP client in the callback.
Yeah.
And I have to set the base address to something. So this is where things start to get complex. Like, what is the URL of my backend? How do I find the backend?
Localhost 5000 /
So it's some random port, and I have to go into my app settings, and I have to find the weather API.
But then if you run it,
properties.
But if you run it in a different spot, it'll be a different URL.
The best part is I open this file, and I think there are 4 URLs like staring at me.
Yeah, which one?
Like, which one do I copy? The one for IS, the one for like HTTP, HTTPS.
Yeah, no idea.
So this is the first challenge when trying to build these applications.
But that one has a semicolon in it. Does that work? I don't know.
It doesn't. So the trick here is like, maybe I want this one. Let's just like pretend I want this one, right? So that's fine. And then when I deploy, like what happens? This doesn't work anymore. So now I have to know the address of my backend, right?
This is the kind of rabbit hole you end up going down as you're trying to figure stuff out.
Exactly. So now I'm going to go into configuration.
Yeah.
And create my own schema and say like weather API.
So this seems like a lot of typing to do. That seems like a lot of typing, and you've still not managed to like actually do the thing you set out to do. Right?
Correct. So this is kind of where Aspire kicks in.
Yeah.
Or at least the first phase where it kicks in.
Yeah.
So I can go here and I can add. It's not here. I think it's add solution maybe.
On a project, not on a solution.
You're right. It's add here.
Yeah, because it adds the. So what happens when you right-click on a project, you can add orchestrator support. The reason it's a project and not a solution is because when you add the orchestration support, it includes the project you right-clicked on in the orchestrator code.
You know more than me, Glenn.
I've always known more than you.
Damn it. All right, let's click on that, and it's going to add these 2 projects, the app host and the service defaults.
Yeah.
And I add that to my solution, and the Visual Studio tooling will light up
some stuff out
beautifully. It's working stuff out. And if I look in my program CS, it has worked out that I want to add this single project to my orchestration.
Right.
Right. So now I have this project that's going to be my launcher, essentially. It will orchestrate anything that has to run as part of my end-to-end distributed system.
Right.
So let's teach it about our 2 apps.
The backend, the API. It's already got the Blazor app because you right-click, so now you need to tell it about the backend API.
Exactly. So I have the Blazor app. Let's call this, let's give it a better name. This is like front end.
Yep.
And let's create a rep to the backend application.
Yeah.
What's super nice about having this all in C#, is I get IntelliSense, I get good tooling, so I can do builder, dot, add, and I see there's container, there's
projects,
executable,
add a RabbitMQ
there's
there
Postgres,
immediately.
RabbitMQ. I don't have to go looking up container images, where things come from. I can kind of use the power of the type system to discover things.
Yeah.
So I can do add project, and let's see what happens. I'll do projects dot, but I only see Blazor app 3. Why is that? So when I added Aspire orchestration, I only added a single project.
Yeah.
I could do the same here. I mean, I could just type, but I'm lazy. So I'll come to my backend and click on add Aspire orchestration support. And it says it already exists, so it won't recreate those 2 projects. But it does do this for me.
Nice.
It injects code because I didn't want to type it. So
good.
I could have typed that, but to show tooling.
Yes.
Let's do this. So I have front and back end. Should call it weather. Let's call it weather. It's by her name.
Yep.
I can copy and paste this.
Because there's going to be more.
There's going to be more, exactly. So I have front end, back end, and I have my weather API. One really cool thing I can do is I can capture a reference.
This is another advantage of this being in a programming language, is you're just using things you're familiar with, references and such.
So I capture an object reference from my add project call, and I can just call with reference.
And give it the backend.
So I'm adding a reference to the backend project from the front end project, right?
This is how you set up the relationships between your projects, and then when you F5, that gives you config and stuff, right?
Correct. And this lets me, from my front end, reference the URL
of the backend.
Weather.
Nice. And no port, because we take care of making that work for you.
Exactly.
And so that weather string there is whatever you called it in that previous project.
Correct.
Right?
So if I were to kind of, let me just close some of my program CSs.
Yep.
Close all but this. Nice feature.
Yeah.
And then I can open up the program CS here.
Right. If you would call that Fowler, if you would call that line 3 there, if you would put Fowler instead of weather, then you would put Fowler in the URL.
Exactly. So if I made this like
Yeah. Cool.
Same thing goes here.
Yeah.
Right.
Cool.
So this enables service discovery to work on from the front end to the back end project. So the last piece is just consuming this service in the weather component. So I can inject weather API client, weather, let's call this weather client.
Yeah.
And I can get rid of my sleep to get paid more money whenever.
Look at that, improved performance by
I make this
some
faster.
percentage.
Man, not having Copilot feels so difficult. Get rid of this thing. All right, we should be good now. So I'm going to build first.
Yeah. Now it looks
it
amazing
compiles.
because we moved all the complexity to a different project, which is what we do.
To a different team.
Yeah.
So Glenn's
right.
team owns the backend. I don't care anymore about what
I see
the
how this
backend
works.
does.
Okay.
I have deferred responsibility to Glenn's team for the weather API. If
Now-
it's done, it's your fault, Glenn.
Now we're doing microservices.
This is
Let's see how
microservices. This is how it works. Disseminate blame.
Yeah.
So okay, let's run this to make sure it works.
Yeah.
I am starting the app host project. So normally in VS, I would have to go to solution, click on properties, check multiple startup projects,
You
and
gotta
then figure out how to kind of add multiple.
Yeah.
And it wouldn't give me the feature of being able to reference the backend just by name.
Yeah.
So let me.
But when we added Aspire support, we set just the Aspire app host
Correct.
already. So when you just run this now, you get the Aspire demo that people have seen, the dashboard and everything, right?
Of course. Yeah, start Docker for me.
Ah, nice.
Even though I don't happen to be using containers, Docker is not required, just so everyone knows. Docker is only required if you do use containers from your Aspire app host.
Right.
VS is just being very nice to me and trying
make sure that
to help me in the future because it knows I want to do container
when
in the
you
future.
and in the starter application, when you're doing file new there is a checkbox that says, do I want to use Redis? And then if you check that, the starter app will actually already have a container reference, and it will then require Docker. But the experience itself doesn't require it unless you want to launch local containers.
That's right.
You don't have to have it there.
Look at that. So the app started, I get this dashboard, and you can see the output says kind of two things. No listening on this port. This is the dashboard port. And it says this OTLP server running at 16.049.
Right. OTLP being PLP being the open telemetry.
The open telemetry protocol. We'll talk about this later on, but let's talk about the dashboard for now. The front end crashed. This is unplanned. This is not part of the demo, but let's actually try to diagnose
Debug an error?
the error with the dashboard. Hosting start failed. Why is that?
Don't know.
Bind address already in use. That's not great. Why was it already in use?
Don't know.
Let's try to figure out.
Do you have a bunch of stuff
So
running?
we have logs, and it's saying that 5226 is already in use. Let's see what port weather was running on. Wait, what? 5196. Did we just get unlucky and choose like a port that's in use?
Pretty certain that's what happened. That looks like what happened.
That's
You've got something else running.
Let's test this. Okay, so the app failed to start. Let me attempt to go to my launch settings and just change this port to like, I think it said that this one's in use. By default, Aspire will use your launch settings to choose the port. You can choose random ports. By default, it tries to mimic whatever happens typically in a .NET inner loop style project.
Which would be this. And this, for those of you who don't know, these ports are randomly generated when you create the project.
At app start.
They don't check,
sorry,
so that could be something else using
so
other ports.
let's just make sure this is actually the case.
Yeah.
Maybe I ran it somewhere else first.
Yeah.
Oh, it was that.
Classic.
Okay, let me just attempt to leave it alone, relaunch. I think I killed the entire thing.
Cool.
Also, you should be able to rebuild individual projects without killing the entire dashboard to make it work.
Yeah.
Okay, so it's working now.
Yep.
Yay! No errors.
Port
conflicts are terrible. I can launch the front end right from the dashboard.
Yeah.
The dashboard shows me the URLs.
Yep. You just saw that you can see errors. Yeah, you have a small resolution so that they all can see it.
Yeah, it's used for debugging. So I just tried to debug the errors, saw the logs for the executables.
Yeah.
I can hit the back end. Let's see if this is working.
Yep.
So Glenn is doing his job. His back end seems to be working.
Yeah.
It's great. If we look at the dashboard again, look at the traces, you'll see why I showed in the keynote where you get this end-to-end distributed trace view.
You can also see in this view that I am definitely not asking anybody else what the weather is, and I must be making it up. Because otherwise you would see weather doing an outgoing request to figure it out.
Exactly. And we can see from the trace view, we see the incoming call to weather, the weather endpoint, the weather page in the front end.
Yep.
This is a call being made, I think, by Visual Studio. So you can see every single call because HTTP client in .NET is instrumented at the core.
Yes. Yeah, you're able to see everything. And then this is super useful when you're like, why is this thing taking so long? Or why is this inefficient? I can't figure it out.
We actually found a bunch of bugs in different libraries just from looking at this trace.
Yeah.
And we found issues, they were fixed.
Yeah.
It was
very cool and useful. Why is that request being made?
What's this request?
Yeah.
2 requests? That's strange. That's the bug in Blazor. That's the bug in X. Yeah.
It's just very easy because of the view that you get. It makes it obvious.
Right. So this is the outbound call. You can see the span, and span is an open telemetry concept. This is showing you all the attributes of the span. You can see the outbound request. You can see the port, the HTTP client call, etc.
These are also structured so you can filter based upon specific parts of this.
And you can see all the logs that were part of this trace. So by default in ASP.NET Core, every request is tagged with an incoming span ID. And if you have a trace ID coming from a separate API call, you get to build this end-to-end trace across multiple services.
Yes.
And that happens without you having to have changed any part of your application.
Even multiple languages, because the standard protocol is standard. So most languages have the ability for this to work for you.
So we lean heavily on open standards to implement these protocols. So it isn't us building our own distributed tracing model. This is just using raw OTLP and OpenTelemetry as is, and then just making everything around the end-to-end experience clean, so you can actually not have to worry about configuring stuff by default. All right. So okay, so this is our end-to-end trace. We saw the front end have the outbound call, and then the weather forecast having a trace as part of that end-to-end, and then the response coming back to the front end.
Yeah.
Very cool.
Nice.
Logs. So let's look at some dashboard features since we're here.
Might as well.
There's console logs, so I can see all the logs from my every service, the front end or back end here. I can see all of the actual outbound calls. I can even go into my app and dynamically change. Let's change the backend because the backend isn't logging much. Let's change the backend. I think we're in development. Let's change the backend logs to be information.
Oh my God.
Intelligence. Oh my gosh. If I hit this request again from the front end to the back end, I should get more logs now. Whoa, 2 weather forecast pages.
Yeah.
If I go to traces, you'll see this end-to-end trace. I should get way more. No.
There is more than there was before, right? But not way more like you expected.
Where are the weather forecast logs? Oh wait, did I change the wrong?
Maybe.
The wrong service?
Maybe.
I did. This is the Blazor app, isn't it? It is.
Yes.
Ha 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 ha. Okay. Same thing again, but for the backend application, the right one.
For real this time.
Save it.
Just so that people in the audience could correct you.
I didn't recompile. I just saved it, refreshed. Don't blow up on me. What are you doing? Oh, I changed. Wait, it shouldn't. Don't blow up.
Yeah, this has been an amazing example.
Hold on. That was the wrong port, maybe. Front end.
Confused of which tab.
That was the wrong tab. Okay, we're good. We're still good. We're still running. All right, let's close these tabs. Okay. App is still running. I should have now more of an end-to-end trace showing, including. Man. You see all the logs?
So many. Yeah, that seems like a horrible idea.
Here's the back end. Okay, so now I have.
What have you done?
The trace.
Yeah.
The back end. I have view logs. I can see weather.
Yep.
Front end. The whole end-to-end trace. So front end to weather, back to front end to get the response.
Because of the response. Yep.
All right.
Nice.
These logs are structured, so I can see the details of every log. I can see all the properties added by individual log calls. Nice. I can extract different fields by adding filters. So you get this kind of comprehensive view of being able to visualize your logs and traces right in development.
Yeah.
I can also
figure out what's going on. Like this thing is optimized for you to figure out what's broken.
Yeah. I think, and one of the big things is I think this makes you appreciate telemetry in the inner loop. Indeed. It's really hard to appreciate the fact that logs and metrics or traces are even working in development.
Yeah.
So this gives you kind of like a really visceral inner loop feeling, so you can see your traces, look at properties, and understand if what you're logging makes sense, right? In general.
Yeah, and you'll be familiar with them when you get the production version of this because something broke there.
Exactly.
And you don't know, right?
Yep.
Yeah.
You even get metrics, so I can look at metrics for my individual services. and you can look at all the metrics being sent from various parts of the runtime, the server, Kestrel, the hosting layer, and you can add your own as well.
Yeah.
And we have these defaults kind of
added a bunch more metrics in .NET 8 as well.
Exactly. Yeah.
Cool.
Very cool.
Next.
All right, so let's move on to how some of this stuff works under the covers. So we didn't spend a lot of time on service defaults in the keynote, but this is one of the places we want to get feedback from customers that use Aspire.
Right.
One of our challenges was how do we have defaults or strong opinions kind of weakly held in Aspire projects? How do we make OpenTelemetry work by default? How do we make health checks work by default? We want an experience where they're just there and they're kind of these cross-cutting concerns shared across all projects. At the same time, we know that maybe in your company or your team, you might have slightly different defaults that you have to conform to.
Yeah.
So our opinions have to be there by default, yet just slightly such that you can change them.
Yeah, we want to get you up and running with what we have observed and use as great production defaults. But we understand that they're defaults and different people's requirements are different. Sometimes you have to change them.
Right.
And the deeper we bake them in, the harder it is to change. And so there was this we thought was a really good middle ground where we give you the code in a shared project that you can reference easily for everybody.
Right.
And you can tweak it and you can change it. The alternative would have been something like a configs file, and then the config schema starts to get very complex, it starts to get very difficult to manage. You don't get IntelliSense and things like that.
This is a final. It is more, this is where we currently are in the first preview. We definitely want to hear your feedback.
Yeah, indeed.
Let's dive into the app and kind of see what we expose by default.
Yeah.
So here's this method called add service defaults. And any typical ASP.NET Core .NET Worker app has these two patterns where you call add, then you call use, for the ASP.NET Core pipeline, and to add services and configuration to DI, etc. So add service defaults configures OpenTelemetry, adds health checks, adds service discovery, which is a brand new component that we authored as part of Aspire, but isn't tied to Aspire. One of our principles was if we have a generic component that isn't kind of tied to the Aspire end-to-end, it will be developed as a separate component, but it will be part of the Aspire packaging stack.
We call it a stack deliberately because it really is a lot of things put together that are all independently valuable, and you could use bits and pieces of it if you really wanted to, and they're all authored and designed to be independent.
Right.
And we're just, Aspire is just the thing that brings them all together and gives you a singular experience. But none of them are very tight. Most of them aren't very tightly coupled together. But the experience of using them all together is kind of greater than the sum of all the parts.
Exactly.
That's what we're trying to achieve.
That's a really good point.
Yeah.
So we add service discovery, and here's a new method in .NET 8 that we added that lets you configure every single HTTP client, factory client that gets created. So you can do cross-cutting things like every single HTTP client that gets created is going to have this standard resilience package built on Poly, V8.
Yep.
And also, I want to turn on service discovery.
Yeah, there's a good point there. So let's talk a little bit about the resiliency stuff. One of the things that happened over the course of .NET 8 is we took a lot of the learnings that we had observed of people using Poly at Microsoft. And then we helped the Poly project, and they did a new major version that is amazing and really fast. If you haven't been watching what's happening in the Poly project, you should go check them out.
Yep.
The add standard resiliency handler uses that, and it just sets up a default policy that we think is good, that you can then tweak. And then you get it for free all the time. So every HTTP request you make is going to retry. It's going to handle transient faults properly. It's going to handle those intermittent weird networky glitches without you ever even knowing.
Right.
You might see a weird log where it's like this failed, but then it immediately retried, and you never have to even worry about it, which hopefully means far less getting woken up or panicking or having a bad outage, because it kind of helps, because it keeps your stuff up longer.
Yeah. And if you have low trust for the team and our defaults, you can change them. So even though this is our default, you can come in here and
put your own policy,
add your configuration, put your own policies in, modify our default policies, change timeouts, circuit breakers, bulkheads. So that is all part of why this is part of your project and in your app itself.
Yeah. Especially if you're already using Poly and you already have a good standard policy that everybody understands, you want to come and throw that in here and not switch it up accidentally on people. Yeah.
Correct. So this line is the magic that makes this code work. Weather. What's happening is, remember the process where we grabbed the URL from launch settings and we copy and pasted it into a configuration option in here to make it work? Think of that same thing happening but behind the scenes, we have this default schema. So by default, when you add service discovery, it adds these resolvers that know how to kind of grab information from different places. One of those places is configuration. So you can actually use service discovery without the Aspire host if you manually just use our default schema and say like services, weather, and then just put the URL here, like HTTP, whatever.
This is just like manually configuring. This is effectively manually configuring service discovery to go somewhere specific.
So the system isn't coupled to Aspire, but used with Aspire, it kind of gels together, works well, right? So even though behind the scenes, the magic isn't that magical. It is what you would have done yourself if you were going to hard code a config, for development and for production. We're just making it easier for you. So we're taking the things that you would have done on your own and making it more automatic.
Right. Makes sense.
All right, let's go a bit further. Here's our default open telemetry configuration. Now, we expect this to get simpler over time because we're working with the team to figure out, what things should be, config-based versus code-based versus not. So I expect this to evolve as we get through from preview 1 to the GA of Aspire.
Indeed.
But by default, we turn on tracing, logging. We wire up the open telemetry logging provider. So all iLogger logs end up going through OTel.
Yep.
And then we also wire up metrics, and we turn on default metrics for various things like the runtime counters. This is part of the OTel project. We also add the built-in meters added to .NET 8. So as part of .NET 8, we added a lot of default metrics to HTTP client, ASP.NET Core, Kestrel, and we had counters before. Like this isn't a brand new concept, but meters lets you add dimensions, so it's a lot more powerful, and you can build like really fancy dashboards that will show off later in the week.
Yeah.
I think Sam and Noah's talk on diagnostics will dive into those details of what these are.
Yeah.
All right, let's keep going. We add tracing, so the distributed trace you saw, the end-to-end tracing, we have for ASP.NET Core, for inbound, and for outbound, we have gRPC and HTTP client by default. And there's more stuff. There's databases, there's Redis, there's caches. When you pull in Aspire components, as Glenn said before, those components bring in telemetry as well by default.
Right.
So
one of the core opinions is that this telemetry system exists and everything that is participating in your whole solution should be feeding into it. And so one of the requirements of an Aspire, for something to be an Aspire component, it has to fit into that world.
Right.
And so if you use the Aspire Redis client to talk to Redis, it is just the normal, it's the same Stack Exchange Redis client you would have used, but we know we've configured it to integrate into this
some magic
world,
around it.
Right? It's configuring it to make sure it sends all of its data to the same endpoints.
Right.
It's making sure it also honors the same resiliency policies. It's making sure that it has a health check that allows us to check whether or not the Redis database is up. Looks like Visual Studio just restarted, because why not?
Oh yeah, okay.
And then that is part of the opinions where we say opinionated, is because we have that opinion that this telemetry system has to exist, everything has to feed into it, and everything that is part of that Aspire ecosystem should do that. And that's how we cut up. That's how we increase your ability to get started a lot faster, because you can just take advantage. You can just rely on that fact.
Correct.
Right? And then you don't have to worry about it or think about it as much. It just exists. You can just you're good, right?
So one of the main things that makes the dashboard, the tracing, metrics, and structured logs view in the dashboard work is this magic right here. So OTLP is the Open Telemetry Protocol. And it's a standard protocol over either gRPC or HTTP that lets applications send traces, metrics, and logs to some endpoint, right? I can egress that information from my app into somewhere. In development, we inject this environment variable, which is a standard Open Telemetry environment variable, OTel exporter, OTLP. That's like super visible. Let me zoom in a bit. So this environment variable is passed into the application, and the app then wires up the exporters. So going from iLogger and meter and activity to the dashboard. The dashboard in this case is your OTLP server.
Right. It also means the same data is available with anything that understands OTLP. It's part of us making sure you're part of that. It's pretty common in the cloud native world. You have Prometheus, Grafana, like there's this whole ecosystem of things that understand this protocol, and we want to make sure that you're set up for that world by default. Even if you're, but also all the other like vendors, you know, as I said,
Zipkin, Jaeger, everything can.
App Insights, like all the things are just more and more supporting this world, and we're setting you up for that.
Exactly. So I think one of the really cool things about this experience is we wanted it such that your code does not have to change in production using standard protocols, using these like standard APIs.
Yeah.
This code can work whether you're in dev against the dashboard, since we implement the protocol as part of the dashboard. When you go to App Insights or any other APM vendor to get like diagnostics, they support OTLP.
Yeah.
This same code doesn't change.
No.
You just have to change what the server points to. Right?
It should integrate into whatever the ops pipeline
ops
is.
flow.
Yeah.
We also have commented out lines to kind of help you get started with things like Prometheus, which are very popular.
Yep.
So if you want to expose a Prometheus scrape endpoint, you can comment this.
Yep.
And you add the package, which is, if you look at there's a bunch of packages here. There's also one for Prometheus. You would add that package.
Yep.
And then we have this endpoint right here, map Prometheus scraping endpoint, that you can uncomment, and it will give you that kind of end-to-end scrape flow out of the box.
Right. Yep. There's where my health check endpoints are different.
It is. Yeah. The last piece is health checks. We have 2 health. It's funny. I asked on Twitter, I think a month ago, we had a debate about what the health check name should be.
Health Z.
So I asked on Twitter, and we had this debate about should it be Health Z or Health, and we chose Health after a little bit of debate.
Yeah.
And there's like different kinds of probes. This pattern gives you a way to kind of define health checks and fit into these 2 slots. You can add more if you want to. These are our default conventions for different kinds of probes.
Yeah. And then as you move into your environment, like Kubernetes has support for probing these things and doing different things based upon whether you're healthy or alive, or they use readiness and such as the name for them. But these are going to be useful. These are mostly good. These aren't as useful in the dev environment, but it's critical often in the production environment.
Very, very, very cool. So that was our kind of default store. These 2 methods, add service defaults and map default endpoints, these were automatically injected by the tooling.
When you right-clicked inside.
When I added Aspire orchestration.
Yeah.
So I didn't show that, but this is to Aspirify the app. You kind of add those 2 projects, and you just call 2 methods.
Yeah.
That kind of shows this isn't that much magic. You can kind of unpeel what happened. I added this 1 call. I added this 2nd call.
Yes. So if you have an existing set of apps that are all already working, you want to make Aspire work, by default, add the Aspire orchestration, you get app host, you get the shared code. Go and call those 2 shared code methods from each of the projects that you want to be part of it, and then go and write the app host code if you're not using the tooling to do what like we just did in the thing, and then you get the same result. And then you can also then slowly work things in. And at that point, even if you do nothing else, you'll have already gained a massive amount of the thing. Even if you don't change your communication to use service discovery or any of that stuff, you'll still get a lot of the telemetry. You'll get a lot of benefits. You probably even get the resiliency and stuff for free because you're still using HTTP client. Right?
So I'll show components, and I'll dive into a little bit of a deep dive and show Dapr, because Dapr came up a lot on Twitter over the last hour or so.
That is an aside while Fowler switches gears there. In the Aspire, there is an Aspire samples repo. In there, we have an example of how to use Dapr. We have an example of a Node app participating in an Aspire project. We have like a version of eShop in there that you can go play around with. So you should go check all those samples out.
Right here,
to be
Aspire
able to,
with Dapr.
Yeah, to be able to see how all this works. And yeah, there was a bunch of interest with Dapr after the keynote. So you're watching us change our demo flow for you live.
Yeah. All right. So
nothing could possibly break.
So let me show a component. So I'm going to go into my app host, and I'm going to builder services. IntelliSense my way to success.
Yeah.
Like and I want to add a container for Redis. So I don't know where that is, but it tells me, right? Add container for Redis. I'll call it cache2 just to make sure that people know that I'm not just calling it cache and it's a magical name. Call cache2, and I'm going to cache from the front end, if I can remember all the steps. And if not, Glenn will help me.
Yep.
So I have now not just 2 projects, but a container.
Yeah.
So under the covers, there's an orchestrator that kind of is running all these projects, much like Docker Compose or any local orchestrator.
For those playing along at home, Fowler has now spent, 40 minutes to get to the point of what the Aspire starter template provides for you out of the box.
But how much did you learn on the way there?
That is fair.
Exactly. I'm going to show another feature where I can right-click on the project, on the project, on the project. That's not the project. This one. Oh no, this is the back end. I want the front end.
Yep, your front end.
Front end has
what Fella's doing here is trying to add a Redis cache and then configure the front end to use the Redis to cache the output of my amazing API, so that he doesn't have to call it as frequently, because I'm constantly
we can't trust you.
calling him and telling him to stop it.
So assume you want to find Redis on NuGet.
Yeah.
Let's try it. So I'm going to type in Redis.
Yep.
And I find it. Oh, great. It's the first one.
Yep.
I'm going to install this, and I get the super awesome Stack Exchange Redis client.
Yeah.
And I don't get telemetry. I don't get config-based configuration. Like I don't get a lot of things that are on by default. Right? So I have to go look for Redis.
Yep.
Open telemetry.
Yep.
I kind of have to do this searching game of like grabbing these 4 packages and then gluing them together to get this end-to-end experience like working.
I go through a bit of this in the blog post if you go check out the Aspire blog post. The steps that the Redis Aspire package actually take care for you is probably 8 or 9 things.
Right. So
by the time you've got the Redis client, the OpenTelemetry bit, the like resiliency bit, and you've configured and wired all those up, you're talking about multiple lines of code, multiple package searches, a bunch of research. And once you've done it once or twice, maybe it's fast. But that first time, you basically won't do it the first time.
What version do you use? Like, so there's a whole set of things whenever you want to depend on one of these super common open source client libraries to call some dependency. So there's this new feature called dotnet, add an Aspire component. Which tries to give you a curated experience.
Yeah. These are just NuGet packages that come from an
They're just
Aspire
packages,
thing.
and there's a filter that we have. They're by default.
We're trying to cut down on the noise if you're looking specifically for these, but they are just under the covers NuGet packages.
And there's no magic. Like I can erase this filter and get the entire NuGet. So we aren't blocking you from using NuGet in Aspire projects. But this leads you to the Aspire Stack Exchange Redis. And I actually want to
want to be able to give you confidence that if you do these things, they're going to integrate with all of that stuff we've just showed you.
Perfect.
The point.
So I'm installing Aspire Stack Exchange Redis output caching.
Yeah.
Let's do that.
Output caching.
From NuGet live.
Yeah.
Nothing cached. Adds like 15 packages, not 15. It's like
a bunch.
A bunch.
But that is actually part of the point. It's like how you would not have found all those 15 packages probably.
Not in the first
Not
take.
until after it fell over in production and you didn't know why, and then you realized you needed to build out extra resiliency in front.
So now I have this Aspire Stack Exchange Redis output caching package. And I end up going to my program CS. That gave me this method. Ooh, not byte. Add keyed Redis, add output cache.
Yeah.
And I want to add Redis output cache.
Yep.
And the name here maps to
the name you put in
the name I put in the app post. That was shown in the keynote as well, right? So I called it cache2 just to make sure people knew
that it's cache2.
That is cache2.
Okay.
I'm caching as well. Caching too.
Yeah.
All right. The magic here isn't too much magic. The way this works is it looks for a connection string called cache2.
Yeah.
So let's say you didn't have the Aspire app post running and you wanted to make the Aspire component work. I could go into my app settings and go into connection strings, cache2.
Yeah, this is another example. You could start using the components before you started using all the rest of it. If you just wanted to get their features.
And the entire point is that we built the stack in a very decoupled way, so you can actually consume components, consume source discovery, consume resilience, any part of the stack independently. So you can gradually adopt, or you can grab the entire thing and have the experience work end to end. That's why it's a stack.
Should if you can, because it is amazing when it all
makes it easier, right? So I could do that, but the Aspire app post actually injects that schema in when I do with reference.
Yep.
So when I did this with reference
in the host,
you'll see this mega comment that I wrote. I'm proud of.
Yeah.
It's pretty amazing. That tells you it will inject the format connection strings source resource name. In this case, it's cache2 underscore some value.
Yeah.
That value just happens to be what it is in development. And in production, it's something else, right?
Yeah, you set that. Can I have that config to be something else?
All right. Let's see if I can make this work now. So I need to add.
So at this point, there's nothing Aspire-y about this.
Nothing at all.
You're just adding the new output.
I could skip this. I could just pretend like this works.
You could. We might as well. We've got like 5 minutes.
All right,
if you want to make some other points.
Okay, perfect. Let's show some more stuff.
You should run it though. To show the Redis.
I should show the cache.
Right?
Yeah, being added.
So we haven't actually turned on output caching here to actually have the Blazor like save the values into the cache. unless Fowler does that now. But what happens now is when he runs the project next, Aspire is going to run a container locally for you that has Redis in it. It's going to set up all the connection strings, and then if you go and modify if you put this output cache attribute on this page, then all of the framework is going to save the actual like HTML render for this page into Redis, and then the next time you come back for a request, instead of executing all this code and generating it again, it's just going to grab it from Redis. And what you'll be able to see is, first of all, Aspire in the dashboard, you'll see this Redis container exist, and then when you go to the distributed trace, you'll be able to see that we check if the thing is there in Redis. If it's not, we call the backend API, and then the next time around we call Redis, and then we just return immediately, and it's much faster. That's the flow here, and that you'll see in a bunch of demos because it's kind of the default. It's also what the starter app is configured to do out of the box. So if you just do file new starter app, that's what it's configured for, to spin up Redis, do output caching, and save all of that for you.
Live demos.
Yeah.
So VS disappeared before, and the process is still running.
Yeah, I'm not sure what sort of state your machine is in. The Visual Studio restarting is like not normal.
That's not normal. Let me just do one more thing and then show, I think, one more important part of this entire thing. Let me kill the Blazor app. All right, should be compiling now. Should be all fine.
So Visual Studio restarted, but it left your app running.
This is a known issue that we're gonna resolve with Aspire.
Yeah.
This is live coding, okay? This is live coding and fun for you because we are normal developers that make mistakes sometimes.
Yeah.
Well, Glenn is. I don't know.
Jeez. Okay.
All right. Front end, back end projects, and I also have a container running.
Yeah.
You can see my cache is running. I can see the image. I can see the logs.
I also expect us to merge these three views at some point.
Yeah, I think so too.
But yeah, at the moment they're all separate.
They're separate right now. Yeah.
But now the container exists the same as all the projects do. And if you go hit the app a couple of times.
If I didn't break it, let's see if I broke it or not.
Yeah, let's find out.
You think it works? You didn't help me, so let's. Okay.
I mean, it works as good as anything could work without me participating.
4. Oh, it works. Perfect.
Nice.
So it cached for 5 seconds. Didn't hit the backend API.
Yeah. Show me in the traces.
Let's see. So we hit, front end only because it's cache. Okay, let's get to the top. Here's where it starts, right here. So I hit the backend.
Yep.
And then it's cached. So it should just actually let's look at this. It hit the backend and then it cached the information in Redis.
Yeah, you can see how the Redis part of this thing is also included in your distributed trace. Yeah.
And by the way, that was wired up by this one call. So I'll just peek behind the scenes for like a slight second. If I F12 and it works like magic. Thank you, Visual Studio. If I add Redis, this component wires up a ton of stuff.
Yeah.
Ignore the code specifics. It is doing open telemetry, DI resolution, like health checks, logging. It's basically adapting primitives of the underlying library to what typical projects
to work
have.
with those opinions that we talked about earlier.
Yeah. One more thing I should show that Glenn spoke about is the configuration schema.
Yeah.
Aspire components can bring in schema.
And they should be part of our spec for what an Aspire component does. Yeah.
So we have this brand new feature where packages can bring in config schema fragments, and they'll show up in IntelliSense live. So I can get the config options for.
So what's happening here is the package has advertised all the things that you can configure, and then you get completion in the config file just by adding the component.
Yeah, exactly.
Yep. And so then that should hopefully help you when you're trying to figure out how to configure a thing.
Exactly. Makes it more discoverable.
Yeah. Even in JSON instead of code.
So you got 1 minute. I'll show the manifest.
Yeah.
Manifest? Okay.
Yeah. So one of the questions we get a bunch is this thing bound to Azure or cloud or anything?
Yeah. How do you deploy it?
Yeah. Well, how do you deploy it? And then also, can I only deploy it to Azure? Because you seem to only ever demo that. And Aspire itself isn't actually tied to any cloud, in any form.
So let me do this thing where I can find my project. The way we support deployment is by not doing it.
Yes.
But we do enough to support being able to spit out enough data for tools to consume for deployment.
Right.
So this morning I demoed the Azure Developer CLI deploying to Azure. The way that works, and if you go to Scott Hunter's talk at 4, he's going to show a deep dive on how AZD and Aspire work together. So I'm going to run this command, .NET run. And
so the point here is that with Aspire, we wanted to be able to express all of your developer your app needs from a developer standpoint, but not try and get into what your app needs in the like production environment.
Right.
Because we felt like that made it unnecessarily complicated and took it further away from the developer. We wanted to be very developer first, developer focused, but make sure we gave all of those ops tools what they needed to be able to participate in this world. We didn't want to reinvent everything.
This is like the best
and
live demo ever.
So yeah.
There it is.
So what Aspire does is generate a file, which is what that command does, that manifest.json, which expresses in a format that can be understood by another tool everything that Aspire knows about your app.
So here are all the resources, cache 2 that we define, type is Redis,
Yep.
weather is a project, and it has all the environment variables, the bindings, etc. This is what other tools use to glean, provision, like figure out what to do with this app model.
Cool. And we are
out of time.
like, I don't know, a few seconds over time. So thank you, everybody.
There's so much more to show.
There is. There is lots more to show. But there's lots more previews too. I think a question time now, right?
Yeah, we are question time.
So maybe someone will ask a question and let them show what you want.
True.